All right, so this whole unit's called transformation. So real quick, I just want to go over what transformations are. It's moving points around in different ways. All right, so I took the Mona Lisa up here and I slide the portrait. All right, I did a transformation. All right, I moved it. All right, and the way I moved it was sliding it. So that's a type of transformation. What else could I do? Oh, I turned it. That's a transformation. All right, it's a specific type, right? It's called a rotation, but it's a transformation when you move a figure or the points. And then, hey, I flipped it over now. There's a transformation. Notice every time I'm moving it, I'm moving it in different ways. I slide it, I turn it, I flip it. And the other one we'll talk about is maybe not. Thought it would blow up a little bit there for me, but oh, there we go. All right, it'll blow up for me. All right, so transformation is moving points around in different ways, reflecting them, rotating them, sliding them, or in this case, making them bigger or smaller. So that's what a transformation is. Now, you'll notice I just went over four different transformations. 3 of them, they didn't change the size, right? Size stayed the same. Stay the same there. Yep. Stayed the same there. Anytime the size doesn't change, anytime the size of it doesn't change, the angle measures and the side lengths do not change. We give a specific name to that transformation. All right. The specific name when the size does not change, where's my notes right here? We're going to refer to that as a rigid motion. So that's the first blank right there. So anytime in this class we perform a transformation where the sides don't change and the angles don't change, aka, anybody got a word for that we've used in the past? Nice fancy vocabulary word. When the size and the shape doesn't change, they remain. Begins with a C, ends in ungruent. Congruent, good job, Boomer. Good, you're on point today. All right, so anytime the size and shape doesn't change, those are rigid motions. Oh, whoa, let me go back to my portrait here. Watch what I'm about to do to it. Not what I just did is not a rigid motion. Why not? Size changed. Okay, size changed. Rigid motion. Did I just do a rigid motion there? Yeah. I don't care what I did. Size didn't change. What about this one? Whew, turned her. Rigid motion? Yes. Okay, so rigid motion, size and shape don't change. Perfect. All right, so now I got to talk to you about what do I call the starting figure and what do I call the ending figure after I transform it. The starting figure, here's what we're going to refer to the starting figure as. A dilation. We forgot to talk about dilation. A transformation that preserves angle measure. The angles don't change, but the side lengths do. And that's what I just had. Where was I? Dilation. Right? Angle measures were still right angles up here, but the size of the sides changed. All right, so let me go back to where I was now. What do I call the starting figure and the ending figure? Not the starting and the ending figure. The figure we start at before we transform it's going to be called the pre-image. The pre-image. So here would be my pre-image. I do something to it. Anybody know what I'm about to call this one? Yeah.
Post image.
I like it. Remove the word post, and we're just going to call it the image. Yep. The image. All right, let's talk about this rigid motion stuff now. The one on the left is my pre-image. The one on my right is the image. Do you think a rigid motion happened? Does this look like a rigid? Remember what a rigid motion is. Angles stay the same, sides stay the same. Do you think this is a rigid motion? Absolutely not, because looks like the angle stayed the same, but what didn't? My side lengths. So side lengths changed. What about number 2 there? Does it look like appears to be a rigid motion from my pre-image to my image? I don't care what I did. I don't know what I did, but when I transform it, does it look like a rigid motion occurred? Yes? Rigid motion, because angles and, I'm not going to write all that, but angles and side lengths stayed the same. All right, our first transformation we're going to cover today is a reflection. Every day is going to be every day in this unit is dedicated to a different transformation. Today is a flip, aka reflection. Notation first, notation, because we do not want to write out the word reflection every time. We have a symbol for it, and I say symbol, it's actually a letter, lowercase r. And no, you can't use uppercase, capital R, because that's reserved for something else down the road we're going to talk about. So lowercase r for reflection. Now, you're just not going to see a lowercase r. You're going to see what's called a subscript, something written down at the bottom of it. And what's going to be written down at the bottom is going to be the line we're going to reflect over. So the line of reflection will be written here. So that's how reflections are going to come for us. So let me give you an example of what one's going to look like before we actually do them on a graph. So here's an example. Ready? Lowercase r, y-axis. That's how it's going to be written for you. So you have 2 pieces. You have the lowercase r, which says, hey, ding, it's a reflection. And then the subscript's going to tell you what line we're going to reflect the point, the figure over. All right, so reflection, what line we're going to reflect it over. All right, let's start actually reflecting. I'm going to take this in slow, probably slower than some of you guys need. Woo. All right, so let's take our point A, 2, -1. Throw that up on the graph for me. Point A, 2, -1. Hopefully you guys can graph. 2, -1. And now let's go over our new notation. Everyone sees the lowercase r. Oh, I'm doing a reflection. Where? Look at the subscript, over the x-axis. So how do I reflect a point over the x-axis? Distance stays the same. And when I say distance, don't get freaked out. I don't mean the distance formula. Right now, point A is how many units from the x-axis, the line I'm reflecting over. How far from itself? 1 unit, which means it's going to go 1 unit in the opposite direction from the x-axis. So I count 1 unit, I go 1 unit in the other direction. There's my reflected point. There's my reflected point right there. Now give me the coordinates of that reflected point. The coordinates of that reflected point, and I got to get better. I got to get my cheat sheet out. Chart. There it is. There's all those beautiful mugs I look at every day. What's that reflected point going to be now? 2 zip. That's period 1s. Look at those mugs. Ooh, you think you guys are bad. Who do I got? 20? 20, Brendan. Yep, I thought so. What do you got?
2-1.
2-1. Yep, 2-1. Last thing we got to talk about, I can't call that point A anymore. Can't call that point A because I just reflected it. I don't want to call it another letter either. So what do I call the reflected point? Anybody remember back in the day? I don't want to call it B, C, D, any other letter in the alphabet. I don't want to call it point A again because point A is right here, and I just moved it. It's a new point. We're going to refer to it as A, but A prime with that symbol right there, A prime. So anytime you reflect a point, we call it prime now. Well, what if I reflect that point again? We call it double prime. All right, we keep going on, triple, etc. So there's 2-1, A prime. All right, let's keep going. I'm going to go to this one right here. Now let's go back to 2, -1 and reflect it over the y-axis. The y-axis. Same thing. Count how many units away it is from the y-axis and go that many in the opposite direction. Oh, there it is. There's this crew. All right, how many units away is A from the y-axis? From the y-axis. Just memorizing these a little bit, huh? It's like finding Waldo.
It's me.
Who is it?
Lily.
Lily? Hi, Lily. Thank you. I knew your name. Thank you, Lily. You didn't need to. All right, go ahead.
Sorry.
No, relax. How many units away is it from the y-axis first?
2.
2 units. Thank you. So I go 2 units away, and it seemed like you wanted to tell me what the coordinates were. -2, -1, and there's A prime now. Good work. Good work. Any issues? Yeah, 18 right there. All right, now I'm going to go to this one right here. I'm going to save that fourth one up here for last. This one right here. Okay, it's not the y or the x. It's the line y equals 2. So we got to review. What type of line is that? Y equals 2. What type of line am I? It's not the y or the x anymore. What line am I asking you to reflect over? Anybody know what type of line y equals 2 is if I graphed it up here? And you know what? If you don't, that's okay. Take those darn calculators right now. Let's use another function on here that we haven't used all year, which is, I forgot what y equals 2 looks like. All right, no excuse. I go to my calculator, go to good old Grapher, right? Graph it. Y equals 2. I just messed all that up. I had it already. This thing. Nope, I want alpha. Y equals 2. Everyone see? Not handled. Oh, yeah, I'll handle it. Yeah, there you go. Okay, how about this? There we go. Change that. Y equals 2. It even tells you before we graph it what type of line it's going to be, so it's a horizontal line. So even if you forget y equals any number, graph it on your calculator and it'll show you. So I need you to reflect over this line now. Y equals 2. All right, same thing. How far away is it? How far away is point A from y equals 2? Count the distance away. How far is it away? Drew?
2.
It is? We're going my original point. It's saying take 2 -1 and reflect it over y equals 2. So how many units away? 3. Good. You all right?
Yeah.
Everyone else? 3 units. So I go 3 units in the opposite direction. 1, 2, 3. Redeem yourself, Drew. What's my new reflected point?
2, 5.
2, 5. There you go. Good. You've been hanging around with people in that group too long. Rubbing off on you. And I don't mean you two ladies. Right? Let's be honest. All right. Everyone good? What if I say x equals? What do you think? What type of line is that going to be? Vertical. There you go. And if you're unsure, graph it. Calculator can graph vertical lines too. So is everyone all right? Before I throw a wrench in the plans of reflecting through horizontal or vertical lines. Count, match it on the other side. Because now what I'm going to ask you to graph is y equals x. I'll just graph it on mine. It'll probably take me 80 years, but I'll try. There we go. Ready for this one? Now I'm asking you to reflect it over that line. Is it horizontal? Is it vertical? So my whole 1, 2, 3, 4, 1, 2, 3, 4 method doesn't work anymore. I can't just match the distance on each side. So instead, what I'm going to have you do, and it's rare in this unit, I'm going to have you remember the rule. All right, just remember the rule of what to do. If any time you reflect over the line y equals x, anytime I reflect, here's what I do. The y becomes your x, and the x becomes your y. In a nutshell, flip them. All right, when you reflect over the line y equals x, you flip the coordinates. Anytime you reflect over the line y equals x, you flip the coordinates. So going back, what does A prime become here now? 2, -1 becomes, when I reflect it over the line y equals x, it will become, Stephanie? That's it, flip them. I didn't say change the signs, I just said flip them. So -1, 2. There's A prime. All right, time to do one on your own now. You're going to take triangle ABC, has A, B, and C reflected in the y-axis for me. The y, not the x, the y. Y-axis. So graph it. Go ahead and graph it. And now reflect it over the y-axis. Well, we never graphed a triangle, or reflected a triangle. If you're just reflecting the vertices, reflect each of the 3 vertices over the y-axis and you have your new triangle. Count the distance away from the y-axis, match it on the other side, and make sure you're calling that new triangle A prime, B prime, C prime. That's it. Take a look, make sure we're good over the y. It doesn't say to state the coordinates, so I don't need to write down what A prime, B prime, and C prime are. It just said reflect it, so all I did was graph it, and that's it. If it said state, then you write the coordinates down. Any issues? I'm going to keep moving. All right, let's roll. Next one. 0, 5. Point X is 0, 5. Where is that? I did that specifically. Is that on the X or the Y? Where if I graph 0, 5, where's it going to be? That's on the y-axis right here. All right, reflect it through the line x equals 2. What type of line is that? Graph it if you have to, but what type of line is it? X equals 2. That's vertical line, right? So vertical line, x equals 2. I want it reflected right there over that line. Distance remains the same when you reflect. So how many units away is x from my line of reflection? Alexi, how many units away?
4.
From the line.
Oh,
2, because now it's got to go 2 away from the line. 1, 2. Here is x prime. All right, so x prime, give me the coordinate for it so I can finish this off. X prime's what coordinate? Lily? 4, 5. Good. Ooh, a little change up now. Please read the directions. Now take x prime. So I'm not going back to x. I'm staying at 4, 5, and now reflecting it through y equals -3. So make sure you know what point you're reflecting. I'm not going back to the original. I'm going back to the image x prime. Ooh, I love this one too. Kids go nuts. So sad here, I did this to you. Y equals -3, a horizontal line going through -3. I love this. This is great. This is great. All right, count it up. How many units away is x prime from that line? How many units away? That's all I want to know. Drew, how many units away? 8. 8! But then you start going, 1, 2, 3. I ran out of graph. I ran out. We start shaking. Hopefully we don't start doing this. Oh my God. Are you kidding me? I'll just extend. I got to count. I got to be able to count. How about do some algebra? How about that, right? Drew just said it was 8 units away. And we're at y equals -3. -3, and I got to go 8 units away. You don't need to keep counting. I hope. You don't need to keep counting. 8 units away from -3. What's going to be my new point? Alexi. I go 8 here, so I got to go 8 here. Where am I going to end up?
4 -11.
There you go. Last thing, what do I call this point? Remember, I just reflected the prime one, so now this becomes, yeah, look at that. Feeling like a boss putting 2 down, huh? Double prime. Everyone all right? Even though we ran out of graph, we can still do it. All right, one more big thing before we finish this off. We've reflected points. We reflected a triangle a couple minutes ago. How about a segment? Can we reflect a segment? Yeah, we can. So go ahead, get at segment FG down, F30. Four, 3. Make sure you connect them, right? It is a segment. All right, part A. I use the symbols. I'm using our new notation. Lowercase r, reflect, y equals x. So remember, that's the rule we have to remember. All right, that's the rule where we have to flip the coordinates. So somebody tell me what f prime is going to look like and g prime is going to look like now. I can't count y equals x. It's not something I can count to the line and count after it. All right, so what's my coordinate for f prime now going to be over the line? Y equals x. Finley, f prime? 0, 3. And how about g prime? 3, 4. There you go. All I do is flip them. So go ahead, watch. I want you to graph this too, so I can show you it's actually being reflected over this line. So f prime and 3, 4. I know some of you may be, did we really reflect this? Hey, remember what this line looked like. That's y equals x. So yeah, fold it over, it'll match up. So yeah, it does look like we reflected it over that. All right, last new line, y equals -x. Reflected over y equals -x. All right, so let me go back to graphing. So there's the line I want you to graph over now, go in the other direction. So new rule. Y equals x. Again, what did we do? What do we have to do to the coordinates? Y equals x? Just flip them. Y equals -x. Flip them, but anybody know what I'm going to add on to it? Change the signs. Flip and change the signs now. So y equals -x, we're going to flip them and change the signs. And again, it's asking us to go back to, take a look, reflect FG. So go back to the original coordinates, flip them, change the signs. Here we go. Makai, here we go. What's F prime? And G prime. All right, there it is. Flip and change the signs. And I promise you that's the only 2 rules I'm going to have you remember. Y equals x, y equals -x. Everything else can be done on the graph counting. -3, -4. And again, remember, just a reminder, here's the line we just reflected over. So this one to this one. All right, definitely looks like it was reflected. All right, last thing, you're gonna do this one for me. I have been giving you the line of reflection all throughout class today. You guys will find it now. So I'm giving you the pre-image triangle and the image triangle. What line did I reflect over? Okay, what line did I reflect over? And write it in the symbolic notation we've been using today, please. What line are we reflecting over here? What's it look like? What line? What's the line of reflection? Stephanie? Do you see where it is? The line I can draw in, so the distance remains the same right here. Got it? Yep. Because it's vertical. It's vertical, so it's got to be x equals, and it's going through 3. There we go. Good. Graph means graph. It's not optional tonight. All right? Graph means graph. Use the graph paper in the back of your packet.